Welcome to the Dragon 9 Media podcast. This podcast is the third in a series focused on learning about artificial intelligence. If you enjoy this content, please subscribe and like this channel to help promote it to others. Hello, and welcome to AI Demystified. Today we're diving into one of the most exciting and powerful parts of artificial intelligence, machine learning. You hear about it everywhere, from your spam filter to the recommendations you get on Netflix. But what is it really? Is it actual magic? Well, not quite, but it's pretty close. At its heart, machine learning, often called ML, is a way to teach computers to learn from data and experiences, much like humans do, but without being explicitly programmed for every single step. Think about how a child learns. They see a dog, you tell them, that's a dog. They see another slightly different dog, you say dog again. Eventually, they learn to recognize all sorts of dogs, even ones they've never seen before. Machine learning algorithms do something very similar. They look for patterns in data to make predictions or decisions. For example, that spam filter in your email. T's learned from millions of emails what spam looks like, those pesky keywords, suspicious links, and what legitimate emails look like. So it can automatically sort new, unseen emails for you. That's machine learning in action. Today, we'll unpack the main ways these systems learn. All right, let's talk about the first major type of machine learning. Supervised learning. Imagine you're teaching a toddler to identify fruits. You show them an apple and say, apple. You show them a banana and say, banana. You're giving them examples, the fruit, along with the correct labels, apple, banana. Supervised learning works exactly like this. We feed the machine learning algorithm a whole bunch of data that's already been labeled with the correct answers. The algorithm then learns the relationship between the input data and the output labels. It's like learning with a teacher who provides all the answers to the examples. So, what can we do with this? Lots. One common use is classification. This is where we want the AI to put things into categories. For example, training an AI to look at pictures and tell you if it's a cat or a dog, that's classification. Your email spam filter is also a classification task, spam or not spam. Another big one is regression. This is when we want to predict a continuous value, like a number. For instance, predicting the price of a house based on its size, location, and number of bedrooms. Or weather forecasting, predicting tomorrow's temperature based on historical weather data. In both cases, the AI learns from past examples where the answers, actual house prices or temperatures, were known. Now, what if you don't have all those neat labels for your data? That's where unsupervised learning comes in. Imagine you're given a big box of mixed-up Lego bricks of all shapes, sizes, and colors, but with no instructions or pictures of what to build. In unsupervised learning, we give the algorithm unlabeled data and ask it to find hidden patterns, structures, or groupings all on its own. It's like telling the AI, here's a bunch of stuff, see if you can find some interesting clusters or relationships in it. A common application is customer segmentation. An online store might use unsupervised learning to group customers with similar shopping behaviors, e.g., those who buy sports equipment, those who buy books, those who are bargain hunters. The store doesn't tell the AI how to group them. The AI figures it out based on purchasing patterns. This helps businesses tailor marketing or offers. Another cool use is anomaly detection. This means finding things that are unusual or don't fit the pattern. Think about your bank. It might use unsupervised learning to analyze your typical spending habits. If suddenly there's a very large, unusual transaction in a foreign country, the AI might flag it as a potential anomaly, possibly fraud, because it's so different from your normal pattern. Our third main type of machine learning is reinforcement learning. And this one is all about learning through trial and error, kind of like training a pet. In reinforcement learning, we have an agent, an AI system that interacts with an environment. It tries out different actions, and for each action, it gets a reward, like a treat for a good job, or a penalty, like a mild correction for a mistake. The goal of the agent is to learn a strategy, called a policy, to choose actions that maximize its total reward over time. This is super powerful for teaching AI to do complex tasks. For example, teaching a robot to walk. The robot tries different movements. If it moves forward without falling, it gets a reward. If it stumbles, it gets a penalty. Over many, many trials, it learns the best way to coordinate its limbs to walk smoothly. You also see reinforcement learning in AI systems that play games like chess or Go. The AI plays against itself or humans millions of times, learning which moves lead to winning, big reward, and which lead to losing. That's how they become so incredibly good. Now, how do these learning processes actually happen? Machine learning uses various algorithms. Think of them as different tools in a toolbox, each suited for different jobs. We won't go into all of them, but let's touch on a couple of important ones in a simple way. First, artificial neural networks, or ANNs. These are inspired by the structure of the human brain, with interconnected neurons or nodes organized in layers. They are incredibly good at recognizing complex patterns in data, like identifying faces in photos or understanding spoken words. When these networks have many layers, we call it deep learning. Think of an ANN like a team of experts working on a problem. The first layer of experts looks at the raw data and passes its findings to the next layer. Each layer specializes in recognizing slightly more complex features until the final layer makes a decision. For example, in facial recognition on your phone, early layers might detect edges, then shapes like eyes and noses, and finally, the whole face. Another common tool is a decision tree. Imagine you're playing a game of 20 questions. You ask a series of yes/no questions to figure out what someone is thinking of. A decision tree works much like that. It creates a tree-like model of decisions and their possible consequences. For instance, a simple medical helper app might use a decision tree. It could ask, "Do you have a fever? If yes, do you have a cough?" And so on, guiding you to a possible cause based on your answers. Each branch of the tree represents the outcome of a test or question. So, as you can see, machine learning isn't just a futuristic concept. It's already woven into the fabric of our daily lives, making things smarter, easier, and more personalized. Think about those recommendation systems on Netflix or Amazon that suggest movies or products you might like. That's ML analyzing your past behavior and comparing it to millions of others to make those surprisingly accurate suggestions. Or virtual assistants like Siri, Alexa, and Google Assistant. They use machine learning, especially a part of it called natural language processing, to understand your voice commands and fetch the information you need. In healthcare, ML helps doctors analyze medical images like X-rays or MRIs to spot diseases earlier and more accurately. In finance, it's constantly working behind the scenes to detect fraudulent transaction patterns, keeping your money safer. So, machine learning is essentially about creating systems that can learn from data to perform tasks, whether it's with a teacher, supervised, on their own, unsupervised, or by trial and error, reinforcement. It's a dynamic and rapidly evolving field. And what we've covered today is just scratching the surface. The ability of machines to learn is transforming industries and creating possibilities we could only dream of a few decades ago. While it might seem complex, the core ideas are about patterns, data, and learning, things we humans do every day. Thanks for joining me on AI Demystified as we explored the fascinating world of machine learning. I hope this has given you a clearer idea of what it's all about. Join us next time as we continue to demystify the world of artificial intelligence. If you enjoyed this content, please subscribe and click the like button to help promote it to others.